Welcome friends to this NPTEL MOOC program on exploring healthcare survey data. We are on the 7th week trying to explore the healthcare data and their panel information. Myself Pratap Mohanty, teaching at present in IIT Roorkee. This particular lecture is targeted to deal with the data of panel through balance or unbalance kind, how balanced panel and unbalanced panel in healthcare data is understood. We will give you the practical handouts to understand the panel data in healthcare. Now, I am clarifying the meaning of panel data. Panel data is basically, as we have already explained, between cross section then as compared to the time series. This is basically repeated cross section data, okay, and it is also called same cross section units over time. So that panel data set could be at the individual level and also could be at the household level. Panel data have space as well as time dimensions. If you look at time series data, panel data contains observations collected at regular frequency. Like cross section data, panel contains observations across collections of entity such as individuals and households. There are other names of panel data such as pooled data, like pooling of time series and cross sectional observations, where the same unit of observation may not be repeated over time, it is simply pooled. Whereas, in case of longitudinal data, a study over time of a variable or a group of subjects, and another one is called event history analysis. We are studying the movement over time of subjects through successive states or conditions. Another aspect or type of panel data is called cohort analysis as well. In this case, we follow the career path of 2010 batch graduates of IIT Roorkee, for example. Okay, so that batch, how it is reflected in different successive periods. When we are catching our analysis for a particular batch, particular cohort, that type of analysis is called cohort analysis. In the case of repeated cross section, the best one can do is to construct a pseudo panel, which is a panel of cohorts of cross section units formed from the repeated cross sections. So, we will have also a dedicated session called pseudo panel. We will be discussing a bit on how to form it. We will also give some example data set for your better understanding. We can study panel data at macro as well as micro level. At macro level, units of analysis can be countries where the number of observation is usually less, okay, and time period is large. In case of macro context, over the time period, number of observations are available, but the time period horizon is quite large in case of macro context. These are also called cross sectional time series data. At micro level, the units of analysis could be of your individual or households or firms where n is large and t is small, t stands for time. These are also called micro panel data. So, now you can differentiate between macro panel and micro panel, alright. Because of its highly informative nature, panel data is increasingly used in econometrics, financial analysis, social sciences and health fields. There are different notations used for panel data, which is distinctive than that of the earlier conventional regression techniques or cross sectional data. In this case, a double subscript is used to denote panel variables. Okay. So, any it is not just one subscript, it is a two subscripts. If it is used, those are actually denoting panel variables. Subscript like I is used for cross sections, or entities, okay. Let it be country or household, individuals, etc. They are called cross sectional subscript. Another is called N, okay. N is stands for number of entities. No, I mean I is your entity, and it matters with how many entities are there, that's called N. So, can be denoted as I stands from 1 to n, okay. So, maybe I varies from 1 to n, that variation you will get it in panel. Similarly, another subscript that is used is called T. T stands for time period, over whether the data is available over month or over year or over quarters, accordingly the T dimension is also given along with I dimension. So, T may also vary from 1 to capital T, T period we have mentioned. So, this double subscript distinguishes cross sections and time series. In cross section we usually have only I, okay, where in time series we have T, but in panel we have both I and T. Therefore, the dimension in total is of I into T, or since I varies from I to n times. So, it should be n times capital T. Okay. So, n T dimensions are actually included in panel data set. Panel data set with k regressors can be represented like the following, as we have presented here. So, like in cross sections we used to have x1, x2, x3, xk and xi and xt xk, at the end we have y variable denoted. Here we are mentioning it is not just x1 I, it is x1 I t. T component is mentioned, this is your T in addition to that. Okay. Similarly, in the y variable we have also added with the subscript called T. So, as we have already pointed out that I varies from 1 to n, then T varies from 1 to T. So, total dimensions, number of dimensions will be n times T. Okay. Now, just an example for your clarity, entity is given, time dimensions are given, the notations that is used is given. Entity 1 it is actually repeated here, then it is n entity, okay. Here it is as entities, and the notations are given as if it is time period 2, it is available for the same entity, okay, and the same entities is also available till the t time period. Then the notations are is equal to y 1 since 1 is here and 1 is there. Then this is 1 and 2 is here, then 1 and t. Okay. Similarly, if n is the entity, then that n is represented in t time period. Similarly, n1, n2 and till nt is mentioned. Okay. Now we are discussing about benefits of panel data. You will get better idea from the Baltagi books. This has listed certain advantages of panel data over cross sections or time series data. The first important advantage is that panel data relates to cross sections over time. The heterogeneity can be also captured in units of observations, okay, that is most important. The techniques of panel data estimation can take such heterogeneity into account by allowing individual specific effects or subject specific variables. Then the second advantage is that with observations that span over time and individuals in a cross section, the panel data keeps more informative data, more variability, less collinearity among variables, more degrees of freedom and more efficiency. So, in all those cases one explanation behind all those reasons is that we are including more dimensions, more frequencies, since your t times component is multiplied with the n number of observations, okay, or to the ith I which varies from 1 to nth observations, that is again multiplied with t. So, dimension actually increased, therefore, we will get a better get the better result with efficiency. Panel data is better suited than cross section data for studying the dynamics of change. Panel data enables the study of more complex behavioral models. For example, the effects of technological change or economic cycle, any sort of effects, even evaluation can also be dealt better in panel data, since it also reduces the individual heterogeneity. Okay, since these are normalized over a period of time, okay, and that is usually present in cross sectional data. Now, we are also identifying certain limitations of panel data, that these data create some problems, such as framing your sample, then getting its coverage. In case of micro panel data, there is high chances of non response in the next round, since you are covering more observations, non responses would be there. There would be we will also show one example data set from India's Human Development Survey 2 as compared to the previous one, and they have given a panel content. We will discuss that how many are actually missing from the previous to the new. Okay, and accordingly the final panel is made, and whether that is going to be balanced or unbalanced, we will discuss. Okay. In the case of macro panel data, there exists cross country dependency, such as correlation between countries. Okay, so since cross country dependencies are always the case in international trade context, so correlation between these countries might exist, then that may create some problem in the panel explanation. Observations are very likely not independent. Okay, that is one another issue, though our assumption is of independenceness, but actually they are not independent. So, over time that not necessarily going to be independent. So, now we are clarifying certain conceptual things like endogeneity issues and omitted variable bias as the limitations of the panel data. Panel data faces a problem of endogeneity and an OVB, that is omitted variable bias. Let us consider a panel data set with the first wave of observations taken at time period t1. If x measured at time 1 t influences y at time t2, we cannot conclude the possibility that a measure of y at t naught does not itself exert a causal influence on x t at t1. So, t naught and t1, whatever is the responses over 2 time period, we cannot just conclude that there is no causal influence. Okay. So, the problem of endogeneity arises because because of the fact that the explanatory term might be correlated with the error term, okay, or the explanatory variable might be also explaining the model because of some correlation exists. Okay. So, endogeneity bias or endogeneity broadly refers to a situation in which an explanatory variable is correlated with the error term. Like we said y is a function of x and x is a function of y. So, in that case your error term is in fact correlated with your explanatory variable, that is x. All right. And this happens because of the repeated information over time, and there might be correlation in the error term. Another problem is that we have to make a panel data, we are supposed to leave certain important variables, observations, so in that way there might be a huge possibility of omitting certain important variables. So, that is in short called omitted variable bias. So, there are some techniques to control these biasness. Now, we are going to clarify you about balanced versus unbalanced panel data. I am just now going to give you the conceptual background about it, conceptual information about it, then at the end we will be experimenting with the data and show you how we can clarify our concept practically. First of all, what do you mean by balanced panel? Balanced panel are the panel where all the subjects have the same number of observations. All the subjects, the entity have the same number of observations that is entered. In other words, it has same number of time observations t should be same on each of the n individuals. So, n and t is expected to be perfect and there is no missing observations. Okay. So, total number of observation is equal to, in that case, is equal to n t. Okay. N time t since no missing observations are are available or missing observations are reported. Okay. Then second one is called unbalanced panel. Then obviously the another side is true, there must be missing observations, all right, and that too all n observations by their time are not available. So, that means different number of time observations on each entity or individual or subject are not available. An unbalanced panel has missing observations for sure. The total number of observation is of course less than that of NT, all right, the total dimensions of the panel. Here is an example for you to clarify a balanced panel and unbalanced panel. Here your A and T, healthcare expenditure and nature of treatment is given, like the N observation is repeated over different time period 2019, 20 and 21. Whereas, this is n times t dimensions we are discussing, whereas the second observations is also repeated with the same time period, all the entries are available. That is why we are saying this is a balanced panel. Second one is called unbalanced because you can just see once, this is one, that is 2019 and 20. So, 21 is missing here, whereas 2 as the n is available in all the 3 periods. Okay. So, 2021 for the first observation is in fact missing in all its information, therefore, this is called an unbalanced panel. So, further to balance and unbalanced panel, we wanted to mention that since balanced panels are empirically easier to handle than their unbalanced counterparts, the empirical researchers often make efforts to create balanced panels. Extracting a balanced panel out of an unbalanced panel leads to an enormous loss in efficiency. We have to make a distinction between randomly missing data and non-randomly missing data. Okay. So, some data points might have been randomly missed, okay, and which are actually deliberately missed, that is a case of concern. If it is randomly missed, still the data set can be considered as balanced panel. Okay. In the case of randomly missing data, most data commands can be applied to unbalanced without causing inconsistency of the estimator. So, once data finds that your missing entries are there, data simply reads as unbalanced panel. Okay. But it is not creating inconsistencies in the result, or the estimator is not inconsistent. Stata can provide us with information to which extent the panel is unbalanced. Once the panel is given with the testing or the command as xtset and the xtdescribe command, then we can understand whether the data is to what extent it is unbalanced. Okay. Now, we will have a practical data set. The practical data set we have taken from WHO sample data set. Those information will also be provided to you as an additional document for your own practice, and we are going to explain all those things. I will I am just referring what are the data set we are considering here. We are observing health data set in Stata, whether it is balanced or unbalanced. We need to check these through these two commands to identify whether the data set is balanced or unbalanced. After that, in the next lecture we can think of running its regression command to the through the reg command, and we can accordingly find out whether that is more suitable or not. That will give you a list of observations that are not dropped. Okay. So, accordingly xtreg command we will explain in detail in the next class, but at this moment I am going to talk about first of all some practical examples. Let us go for it, then we will also stick to other aspects. Okay. Now, here is our data. I am just opening it for your reference. Now, I am going to the file, then importing the data. This database we have taken from the WHO. This is in Excel based format. Now, I have opened the unbalanced data. Okay. So, unbalanced data, but we need to specify which row is considered to be the variables. It has taken the first row. Okay. We have opted for it. Now, we are going to make it okay for it. Then I am going to open the command, going to run the command to understand you whether the data is in fact unbalanced or not. We have opened though an unbalanced panel. I am just going to specify it. Okay. So, I am giving you 2 dimensions. One is the ID, that is the observation dimension. Second one is time dimension. Okay. So, now with the enter we can find out the result. The xt set is defined through its ID variable and year. Now, you can see it has clearly identified the data is unbalanced. Okay. And the data is available from 1993 to 1997. Alright, this has obtained a delta method to find out whether there is any missing observations, okay, or missing time period. So, now we will check it is described details. Okay. xt describe, that will clearly highlight where exactly the data is missing. Okay. Data is defined as an unbalanced. Now, you can see out of 39 observations, the 25 observations where the pattern is explaining at the end box. You can see in the pattern 5 times 1 is written, at the end. Here it is written as 5 times 1. Okay. So, 5 times 1 means these 25 observations are actually repeated in all 5 time period as provided by the WHO data. There are 13 such observations where only the last time period information is the latest time period entries are there. Only one case, one observation where first 4 time period are available, but the last time period it is in fact missing. Therefore, the data has earmarked as unbalanced. Okay. So, next we are going to open the data set to highlight or to understand the balance panel, isn't it. So, so here I am going to open a kind of panel data which is balance one. We have again taken from the same source. So, WHO balance panel data, it is on healthcare issues. We will also share with you. We have identified here as the variable as the first row. Now, with the same commands like xt set, it will confirm us whether this data is balanced or unbalanced. Okay, with the ID variable and the time variable is here defined as year. Now, you can see that the xt set command, xt is the standard command in panel. So, xt set is confirming us that your data from 1993 to 1997 is a strongly balanced panel. Okay. You can also check its description as well through the xt describe. Okay. These do files are also shared to you. Now, you can see all those 33 observations are actually repeated in all 5 time periods. So, 111 5 times is mentioned. So, all 5 time period all 33 observations are available. So, I think this is not problematic, and I am sure you can easily understand in any database whether it is a panel or not a panel data. Okay. So, that is where we explained. Let us move to the understanding of other data set. I will also clarify some other concepts related to panel like short panel and long panel. On the basis of time dimension, panel data is classified as short panel or long panel. So, like if depending upon the time, data on many individual units and few time periods like n is higher than that of the T. If it is the case, that is called short panel or that is called micro panel. Just the reverse is observed in the long panel or in the macro panel. So, long panel are also called macro panels. Okay. So, the long is the word refers to mostly emphasizing the time. Short panels are more common than long panels. The estimation techniques depends on whether we have short panel or long panel. We are now exploring in front of you about ISDS data, India's Human Development Survey. This gives panel observation, and this is in fact a micro panel data, okay, where n is higher than that of t. T here is only for 2 periods. Okay. So, we are going to open it, and there are number of observations are of 41,554 and households were surveyed for 2 periods in ISDS 1 and ISDS 2. Okay, that we have already discussed something about this ISDS. You can also search in website India's Human Development Survey, you can able to get it. So, ISDS data set is an example of short panel data. Okay. We can easily convert wide form to long form or vice versa in Stata with a simple command called reshape. So, like a wide panel where number of cross sections are much higher, okay, and or time dimensions are much higher. If it is so, then we can actually flip it through reshape command. ISDS provides panel data in both wide and long format and linking files. If you are interested in creating a panel yourself, it will be this is going to help you better. Now, I am going to show it here about this ISDS data for your better understanding. So, I am going to clear the data we have already cleared. Now, we are going to open the ISDS data in front of you. Now, first of all, we need to understand which are the common ID or the ID variables, and those should be uniquely identified in both the panel in the panel data. So, we are generating a ID variable. So, eGen is the command is equal to as per the instruction given in ISDS. You can search in Google in their web page. So, we are making an ID variable through this command. Okay, and there are 5 important variables, that is HH base, state ID, district ID, PSU ID, starting from once again there will be 5 variables starting from state ID, district ID, PSU ID, HH ID and household split ID. Now, you can see that state ID is mandatory, then state, then districts, then PSU, then primary sampling unit, then you come to the household level, then how household is getting split over time period, who are the final households. So, that is a split ID is important. So, now we have defined an ID variable. So, ID variable with the name ID. Now, we can check whether these are actually uniquely identified or not. So, ISID is the command for ID variable we have defined. Now, at the end it is there. Okay. And the time dimension has to be given as well. So, survey period is in fact the time dimension as per the data. So, that means this is our these two are in fact uniquely identified, since it does not throw any error. Okay. Now, we can check whether this is a balanced or an unbalanced data. So, XT set is the one through the ID and survey. Okay. So, we can check whether this is a which form of data. It suggests that it is a strongly balanced data. Okay. Strongly balanced data, the time period is from 1 to 2, as I already mentioned. We can also check its description if you want, the way we have already guided. Okay. Also, we can check it through the browsing window. Once BR window or through the display, we can able to get it. So, these are all the information in front of you, and you can check. Okay. And since there is no missing points, so the data, even if it is there, but by the time and the cross sections it has already covered. though missing dots are there, but Stata reads that there are certain entries. So, it is considered as a balanced panel, okay, hence a strongly balanced panel. Now, this helps you to work better with the panel data. I hope I have given a correct direction at this moment. We will be explaining about pooled fixed effect over random effect, etc., and its applications interpretation in the next class, and I look forward to your participation. Okay, thank you.